Hello everyone. I think you all have gone through the first lecture. Before moving to the today's lesson, I would like to give you the reference for this course unit. There are three references in here. The reference text 2 and 3 are available in the internet. You can Google it and download. But I think first one is not available. After reopen the university, you can go to the library and get that book for reference. Okay, now we will move to the today's lesson, chapter 2, Fundamentals of Algorithms. As you can remember, in the last lesson you got an idea about what is computer program, what is meant by programming languages, types of programming languages, and the 7 steps to develop a computer program. I described the first and second steps in there. Now we will move to the third step, develop an algorithm. As you all know, in order to solve any problem by using a computer, we write computer programs. Before writing programs in any programming language, it is better to write a description of the solution. Simply an algorithm. An algorithm is a set of steps used to complete a specific task. They are building blocks to the programming. First, we start with the input data and do the complex calculations or follow a procedure to get the output and stop when we got the answer. It is not having one possible way to write down an algorithm. There are other ways. Different people will write different algorithms to do a same specific task. For example, we can get the Google map. In the slide, you can see a part of a Google map which shows the paths to Colombo Fort Station to Kadavata town. When we give the inputs to the Google map from Colombo Fort Station to Kadavata town, using algorithms, it finds the possible paths. In here, there are 3 paths. After that, it searches what is the most suitable path to reach the destination. They are using route finding algorithms for that. And this is a simple example for choosing the best using algorithms. What makes a good algorithm? There are 2 most important criteria to choose the most appropriate algorithms. First one is correctness and the second one is efficiency. What means the correctness? Correctness means that solves the problem. And efficiency means the use of the time and the memory. In the time, which one could execute faster, and the memory which takes less memory in the computer. Then less time and less memory makes good algorithm. But sometimes the algorithm that gives the most suitable correct answer get too many time to execute and get more memory in the computer. So we are using asymptotic analysis to get the most suitable algorithm. And finding good algorithms and knowing when to apply them will allow you to write interesting and important programs. That is the basic idea about the concept of algorithm. Now let's talk about the procedure involved in designing an algorithm. Writing an algorithms. Normally algorithms are written using English-like language so that it is easily understandable even by the non-programmers also. It is writing like step 1 as the first step what we want to do, and the next line step 2 what we want to do as the second step, and the next line step 3 and so on until we get the required output. But in here we are going to talk about the algorithms that are written using pseudocodes. Pseudocode is a language similar to the programming language to be used. Then it is normally used by the programmers to get the idea and the solution of the problem. And here I have given the format of the algorithm that we can write the algorithms using pseudocodes. First, we write main, the keyword, and the name of the algorithm. After that, we are using hash symbol in here to indicate the comments. So in the next line after the algorithm name, we have to put hash and explain the purpose of the problem or algorithm in one line or two. Then other people can understand what is the algorithm about. That's why we are using comments to give the idea to the others what we wrote. Next, we want to give local data. It means we have to define the variables, the inputs and the outputs of the problem. Then we can begin to write the main body, the procedure of the program. It is starting with the keyword begin, and after we are writing the procedure. Then we are using keyword end for indicate that we have finished the procedure writing. After that, in last again we have to give the keyword end for indicating that we have finished the writing of the algorithm. Okay, now this is the basic format of writing an algorithm using pseudocodes. It can be some differences in the format in the other resources, but basically all are same. I have given a task for you in the last lecture. If you can remember, I told you to try to write an algorithm to get the multiplication of two numbers. And in there, I have created the defining diagram for it. In here, again in the slide, I am displaying that. For get the multiplication, input variables are value 1 and value 2. Output variable is multiplication. And in the middle, I have given the description of the procedure. First, read two numbers, then calculate the multiplication, and then display the multiplication. Now let's see how to write an algorithm for this. First, we have to write the name of the algorithm. In here, we are going to find the multiplication of two numbers. So I am giving the name multiplication to this algorithm. You can use any relevant name as you prefer for the algorithm name. Then comments. Comments are not compulsory. If you don't want to have them, just ignore that. But comments are good practice of programming. Not in here, but also when you are writing codes, practice to keep the relevant commenting, because it gives an idea to others that what you have done in there. In here, I have written program accepts two integers and outputs the multiplication of two integers. It gives an idea to anyone who read this that what I have written here as an algorithm. Next, local data. It means variables that we are going to use in the programming. We have two inputs, value 1 and value 2, and one output, multiplication. Then I have given the data type as integer. Integer is a data type we are using in programming to indicate the numbers. We have string, char, double, float, and many more data types in programming. Later I will explain what are the data types in programming and how to use them. Now just get a brief idea about data types. Value 1, value 2 and its multiplication give us a number as written. So all are integers. Then we can start to write the procedure or step by step how to get the multiplication. We can start with the keyword begin. Then we have to input the data into the program. Input value 1 and value 2. Then get the multiplication of two input values and store it is in the variable multiplication. Finally, we have to display the multiplication. After completing the process, we have to write the end keyword for showing that we have completed the writing of the procedure. Then again by an end keyword, we can tell we have finished the algorithm. This is one of the sample algorithm that gives the multiplication of two numbers. We written this as a pseudocode. Now let's see another pseudocode algorithm for the same problem. Starting with the main algorithm name multiplication, then comments as earlier program. Next, input output variables with the data type, all are same as the earlier program, but the procedure is different in here. Begin. In this algorithm, first we need to ask from the user to give the inputs. To give the command to the user to get the input, we have to display a message as enter two variables, two values. Then after user type the value 1 and value 2, we have to get those two values as input. Then multiply the value 1 and value 2 and must store the result in the variable multiplication. Then again we can display the result as output by giving the multiplication is this. Then we can end the procedure and the algorithm. What is the difference between earlier algorithm and this algorithm? In earlier algorithm, it did not interact with the user. We just give the two numbers and got the multiplication. But in here, first we got the input by the user and get the multiplication and display the results to the user with the message. Like that, we can write several algorithms with different number of steps with different procedures for the same problem. There is no exactly one algorithm for one problem. There can be 10 different algorithms from the 10 students for same problem. It doesn't matter. We only have to care about that all algorithms are giving the correct output. Then it's okay. Naming conventions. In here, I would like to give you a brief introduction about naming conventions. A naming convention is a set of rules for choosing character sequence to be used for identifiers which denote variable types, functions, and other entities in the source code and documentation. Naming conventions are mostly used to improve the readability and the consistency of the data. In algorithms, we can use naming conventions to algorithm name, data variables, and function names, and like that. The first one is data names composed of letter or combination of letter and digits. It can have uppercase letters A to Z, lowercase letters A to Z, and numbers 0 to 9. Then the second one is name must be started with a letter. Don't start a name with a digit. For example, first var1 is a valid variable name and 2var is not valid. The next condition is in here algorithms. Names are case insensitive. It means uppercase letters and lowercase letters considered as the same letters. For example, in here total that start with the capital T and the total that start with the simple T are considered as the same name. But you will learn in C language those are different because C is case sensitive programming language. So in there uppercase letters and are different from lowercase letters. In there above two totals are different, not the same. The next rule is The special characters like at, percentage mark, power, and mark or asterisk are not allowed in the name. But underscore is allowed, but mostly we are using underscore as the start letter in the system variables. And also you can use the underscore in between the words in the name. Blanks or white spaces are not allowed in between. Because, for example, say my variable, compiler or outside person who reads our algorithm will recognize that as two words, not as one variable. For avoid that, we can use underscore in between the two words. And next, don't use keyword as the variable names. For example, if, else, integer, while, double, and etc. Those are reserved words. Don't use them as the variable names. Then this is a tip. Don't use very long variable names because it is not good and it is very hard to write again and again in the algorithm procedure. So keep them simple. And another tip is use Pascal case for the algorithm names. Pascal case means if the name contains multiple words, start each word with a capital letter. For example, you can see in total students, T and H are capital. In tax payable, T and P are capital. There are some other cases in the name conventions like camel case, which start with a simple letter and the other words starting with a capital letter. Camel case is mostly used by the variable naming. In here I am suggesting use Pascal case for algorithm names. Those are the naming conventions we must follow in here. Explicit data definition. It means we are required to give the definition of data variables or data items before we have to use them in the procedure. If we have not defined it before, there can be errors occur. From the previous example, you can see we defined the variables as value 1, value 2 and multiplication. All are want to be integers. After that, in the procedure, we used an equation multiplication equal value 1 asterisk value 2, which gives multiplication of two values. Before using that equation, we must define the value 1, value 2 and multiplication as we have done. Then implicit data definition. It means we are giving the definition of data variables or data items when we are using that variables in the procedure writing. Some programming languages allow this and some are not. Implicit code can be a very nice experience if things are well named, as it keeps things simple. But it can also be a difficult issue to solve when you done wrong. But explicit code makes the code clear. When you look at it as the specifics of what is being done is already can see easily and you don't have to track down issues elsewhere. But generally you have to write more for explicit code. So there are pros and cons in both. Next, this is very important topic, data types. You have to learn about data types because when processing data by using computers, you must specify what type of data to be processed. Simply, data can be stored in many different formats and it is called as data types. In general, we process three types of data. First one is numeric. It means numbers. And the second type is textual. It contains characters and strings. And the third type is logical. It means true or false. Programming languages provide a set of keywords to represent these data types. For example, char for characters, int for indicating integers, byte, then float and double for decimal numbers, strings, booleans, like that. And also another fact is there may be several keywords for represent one data type. For example, byte, short, int, long, all keywords are used to represent integer type, but the range of that types are different. Okay, what is a data type anyway? A data type is a combination of collection of items and collection of associative operators. For example, a set of integers like 1, 2, 3 and arithmetic operators like plus mark, minus mark, asterisk and division mark form an integer type. And different integer types are defined by changing the item set. It means number of integer values. And the most importantly, any set of items and any set of operators do not form a data type. For example, true or false and arithmetic operators like plus mark, minus mark do not form a data type because true and false are logical values and arithmetic operators cannot be applied with them. Now we will see the most commonly supported data types in programming languages. First we will talk about numeric data type. First one is integer. An integer data type stores whole numbers. That numbers can be both positive or negative, but they cannot contain decimal points or fractions. Examples for integers are 5, 2007, minus 100, like that. And I think you can remember in the first example in algorithms, we wrote the local variables as value 1, value 2 and multiplication, and the type of those variables are integer. Like that in here you can see the example counter colon integer. We can state the integer type variables in the algorithms as variable name colon integer. The next type is real. A real data type is a numerical data which contains decimal numbers. We can store integers also in here. For example, we can state 1.414, 17.65, 205 and minus 4. In the algorithms, we can state the real type variables by variable name colon real. In the slides you can see average colon real. When we get in the average, sometimes it can be decimal numbers and sometimes we can get whole numbers. So we are giving it as real type. Then we will move to the textual data. One type is character, which stores single character which can be a letter, number or a symbol. You can see the example in here, simple A, capital F, 3, $mark, hash, all are characters. In the algorithms, we can state the character type variables as variable name colon character. Here I have given the example flag colon character. Flag means a value that acts as a signal for a function or process. The value of the flag is used to determine the next step of a program. The next type is string. A string data type stores alphanumeric combinations and text. String is really a group of characters stored together as one. Earlier in character type, we can store only one character, one symbol. But in here, string type, you can store any sequence of characters together. For example, hello world as one string, John 1, 2, 3. Like that, we can store any combination of characters. Numbers to be used for calculations should not be stored as strings, even though they can be. They should be stored as integer or real. And in here also we can store string type variables in the algorithms as variable name :string. In the slide example you can see message :string like that. Now we can talk about logical data type. The only logical data type is Boolean. A Boolean data type contains only two possible values, true or false. Sometimes it taught as 1 or 0, where 1 indicates true and 0 indicates for false. Normally Boolean data items are used as status indicators or flags. In the algorithms, we can give the logical data as variable name :Boolean. In the example, you can see end of file :Boolean. It can be true or false only. Let's see some basic arithmetic operators used in algorithms. For addition, we can use plus mark. For subtraction, minus mark. Multiplication, asterisk. Division by /, assignment by equal mark. Exponentiation by wedge. Integer division by div. To get the remainder of the integer division by mod. And the brackets for grouping the calculations. This is basic arithmetic operators. I think you all know about those very well. Next, data usage. We can consider data as two types. One is variables and one is constants. Variables. Variables are data items of any type whose contents may change as the program executes. For example, we can get counter equal counter +1. This is a line of an algorithm procedure. In the beginning, counter value is 0, then counter equals 0 plus 1 equal 1. When the program procedure executes once, then the counter equal 1 plus 1, that's equal to 2. Like that, in every execute, counter value will be changed. So counter is a variable. Then constants. Literal values or data items whose contents do not change as the program executes are known as the constants. For example, we can use 5 value as a real data type, value 3.142. When program executes, it will never change. In every execution, 5 value is 3.142. That is a constant. Now let's see an example for recognized variables. This is an algorithm to read a number and update its value after increased by 10. Then you have to give the output value. For example, if you got the input as 5 from the user, then you have to add 10 and give the output as 15. So first, what are the inputs? Input is a number and its data type must be integer. And what is the output? You have to give the same number which we get as the input, but it should be increased. So we can write the algorithm now. I have written the algorithm name as increase num. So main increase num. Then I have given some comments what is the algorithm is about. This program accepts one integer and increase its value by 10 and output the answer. After that, we have to define the inputs, outputs and the variables that we are going to state in the program procedure. Local data. Then the only variable we are going to use is number and its data type is integer. Now we can write the procedure. Begin. We have to get the input by the user, so we need to display a message in the screen to get that. Display, enter a number. Then we have to get the input as that number. Next, the main thing, we have to increase that number by 10, and again we need to assign that to the variable number. So we can add 10 and store that in the same variable. And at last we have to display the answer as the answer is the increased number. Then ends the procedure and the algorithm. So in here number is a variable, because in the first before it increased by 10, its value is different, and after increase its value it is different. As I earlier told, if user gives 5, then at that time the variable number equal 5. After increasing by 10, the variable number equal to 15. So value is different and it is a variable. Now we will see an example for recognized constants. This is an algorithm to find the perimeter of the circle, or we can say circumference. As you all know, we can get that from the formula 2 pi r, where r is the radius of the circle. Now let's see how to write an algorithm for that. First, what are the inputs? Input is radius, because the formula is 2 pi r. We know the value for 5. We only want to get the radius of the circle by the user. And radius can be a decimal value, so we have to use the data type as real. And outputs. What are the outputs? There is only one output. You have to give the perimeter as the output. Perimeter also can be a decimal value, so its data type also real. Now we can write the algorithm. Main, I have given the algorithm as perimeter. Then comments, program accepts radius of the circle and then find the perimeter and outputs the answer. After that, data definition, radius, perimeter both must be real. Then we have to give the value for 5, that also a real value, 3.14, because 5 is also a data. And now we can write the procedure. Begin. We have to get the input by the user. So we need to display a message in the screen. Display, enter radius. Then we have to get the input as radius. Next, calculate the perimeter by 2 multiplied by 5 value multiplied by radius, and store that value in the perimeter variable. And at last we have to display the answer as the perimeter is the value we got. Then ends the procedure and the algorithm. So in here 5 value is a constant, because we can execute the program with different radius values, but 5 remain as the same. We are using the same 5 value, 3.14, so it is a constant. Data scope. In here also there are two types. One is global and one is local. Global data. Global data is accessible from within the program in which global data is declared, or from within any other nested programs which are directly or indirectly contain the program that declare global data. In the algorithms, we define data outside of the procedures. It can be accessible by any of them. For example, you can see we define data outside of the procedure 1, procedure 2 and procedure 3. So those data can be used by any of the procedures. Those are called global data. That global data can be data names, variables, constants, file names, or any data. The other one is local data. Local data is accessible only from within the program in which the local data is declared. Local data is not visible or accessible to any program outside of the one where it is declared. In the algorithms, if we define the data within a procedure, it cannot be used by another procedure. It provides privacy within any procedure, thereby preventing its access and possible corruption by other procedures. For example, you can see we define data for each procedure separately. Those are local variables, so other procedures cannot access and change the local data. Okay, there is another part to complete in this chapter. I will upload that part after 3 or 4 days. And I have uploaded a worksheet for this lecture also. It contains the basic things about data types and algorithm writing. Try to do that. If you have any question, you can email me. I have given my email address in the first slide. And also I have uploaded the PDF version of these slides. Find that and the worksheet. Thank you.